This equation here is an example of a literal equation. We have 1, 2, 3, 4 variables, and right now it's solved for f. So if we were to know the values of r, c, and z, we could substitute them in here, compute, and get the value of f. But now, what we want to do is we want to rearrange this formula and solve it for r, so we have r equals something. So let's see what we want to do. We want to isolate r. Now, it looks like r is being multiplied by this quantity here. Now keep in mind, any quantity in parentheses is just one single term. Or one single thing. It's just got a longer name, that's all. So this quantity here is multiplying by r. So to eliminate that, what we should do is we should divide by c minus z. Make sense? What we have is that c minus z is multiplying r, so to undo the multiplication, we'll do a division. We'll divide by c minus z. So if we do that, we'll get f over c minus z equals, now I'll go ahead and write it this time, but normally we wouldn't do this, c minus z over c minus z. Those cancel, and we're left with this. R is equal to f over c minus z. Now, in the original formula, back up here at the top, if we knew r, c, and z, if we knew those numbers, we could substitute them in here, compute, and end up with f. Now, if we know f already, and c and z, we can compute here and get r. Here's another literal formula, number 2. We have b equals h, n, u. So if we knew the values of h and n and u, we'd just put them in here and multiply them together, and we would end up with the value of b. But what we want to do is we want to rearrange this formula so we have it solved for u. So we want u equals something here. So we're trying to solve for u. Now notice that u is being multiplied by hn. So if u is being multiplied by hn, we can undo that multiplication if we just divide by hn. And things will look like this. b divided by hn equals, now let's not write everything here. If we divide this side by hn over hn, they cancel out, and we are just left with u. So we can write it this way, or if you like, you can write it u equals b over hn. Number 3, another literal equation. So what we have is we have the variables x, a, and n. And right now, if we were to know x and a, we'd substitute them here and compute, and we'd end up with the value of n. But what we want to do this time is rearrange this equation so that we have it solved for x. So I don't think there's much to do here, do you? I just want x by itself. We're subtracting 6a. So why don't we just do this? Why don't we just add 6a? That will isolate the x. And if we add 6a to this side, negative 6a plus 6a is 0. That's gone, so we'll just get x equals, now add the 6a over here to this side, and we'll get n plus 6a. In number 4, this literal equation you can see is solved for d, and what we want to do is rearrange it so we have it solved for a. Now here's what I see right away. We have a division going on here. We're dividing by p. Now, as we always do in equations that involve fractions, we're going to get the LCD, and the LCD here is just p. And then we're going to write that LCD alongside each of the originals. I'll put it here, and I'll put it here. Let's do that. We'll get d times p is equal to p times a b to the 4th over p. This will give us dp equals, now these p's cancel, and we get a b to the 4th. And one more step, right? We want to solve it for a. It's being multiplied by b to the 4th. So we can undo that multiplication if we make a division by b to the 4th. So we're going to divide both sides by b to the 4th. And our equation will look like this. dp over b to the 4th, that's now equal to a. And if you want to rewrite it so the a comes first, a equals dp over b to the 4th. Now here, number 5, here's this literal equation here. We want to solve this for g. So instead of having it solved for z here, we want to solve it for g. So look what we have. We have an equation with fractions, and we always handle these the same way. We're going to get the LCD, and the LCD here just is PG, and then we're going to multiply every term by the LCD. So what we're going to do is write the LCD here, and then write it here. We will get PG dot U over PG equals PG dot Z. On the left side, the PG's will cancel, and we are left with U equals PGZ. And we want to solve this for G, so we need to eliminate the P and the Z. Now notice, G is being multiplied by PZ. So why don't we eliminate that PZ by dividing by PZ. That'll give us U over PZ equals G. And we've got it. I'll just rewrite it. So G equals U over PZ. So let's solve W equals 4D over N. Let's solve this for N. So our LCD here is N. So we're going to do what we always do. Write that LCD alongside each term. I'm going to write it here. I'm going to write it here. We will get W dot N equals N dot 4D over N. This N over here will cancel with that one. And now we'll get Wn equals 4D. And I'm trying to solve it for N. It's being multiplied by W. Why don't we divide by W, and that will give us N equals 4D over W. So what we have here is this equation here with a C, an M, an R, and a T as our variables, and we want to solve it for T. Now, here's what we could do. There's two things we could do here. I see T is inside the parentheses. I want to eliminate those parentheses, unlock the parentheses maybe, and have that T available. So here's one way we could do this. Like, it seems like a natural thing to want to multiply through. We can do that. Let's just multiply through. We'll get C equals M times 1 plus MRT. And this M times 1, that's just M. Let's just write this. C equals M plus MRT. So let's subtract capital M, and it's this M right here that we're subtracting. So we're going to get C minus M equals, and if we take M, subtract M, we'll get 0, so that term is gone, and we'll get MRT. And I'm trying to solve this for T, and I notice that MR is multiplying it, so why don't we just divide by MR? So we will get C minus M over MR. That's all equals to T. But now I could have done this. All right, so here's another possibility. I divided the whole side by MR. We could just divide each individual term by MR. Now if we do that, we're going to get this. We're going to get C over MR minus M over MR equals T. And if we do this, those M's will cancel, and we'll get C over MR minus, now when there's a cancellation line, there's really a 1 there, 1 over R equals T. Now both of these are correct, they just look different, but when you compute, you'll get the same result with either one of them. Now in number 8, we're asked to solve this equation here, this literal equation for y. Well, there's not much to this. Look, y is right here. All I have to do is add 3, and we'll have it done. So I'm just going to say add 3, and if I do that, I'm going to get y equals 2/3 x plus 3, and then I'm adding 3. So there's a solution. And I think this is fine right here. But it could be that the textbook wants us to write it like this. Combine these terms here. So here's what we'll do. I got a fraction. The LCD here is 3. So why don't we just multiply everything by 3, right? What do we do with the LCD? You put it in front of all the original terms. I'll put it here, I'll put it here, and I'll put it here, right? I got that term, put the 3 there. I've got this term, put the 3 here, and I've got this term here, put the 3 here. So now it looks like this. 3y equals 3 dot 2/3 times x plus 3 plus 3 dot 3. So I just put the LCD. Here, right here, 3y. Then I put it here, right here. And then I put it here. There it is there. Now, let's just continue on. We'll get 3y equals, now notice that these 3's cancel, and we get 2 times x plus 3 plus 9. Let's multiply through. We'll get 3y equals 2x plus 6 plus 9. We can do the 6 plus 9. We'll get 3y equals 2x plus 15. And now there's 2 ways we can go here. What we want to do is get y by itself. So we are going to divide by that 3. So I could divide the entire side by 3. That would look like this. Y equals 2x plus 15 over 3. That's perfectly okay. Or we could divide each term by 3. Divide by 3, divide this one by 3, divide this one by 3. And if we do that, things look like this. Y equals 2 over 3x plus 15 over 3. And the 15 over 3 we can simplify. We'll get y equals 2/3 x plus 5. So the book is going to probably write one way, not both. But both of them are good. Number 9. We have b, w, n, and t. We want to solve it for n, so we want n equals something. It's a fraction, so get the LCD. Now the LCD is right here. It's the only denominator. So the LCD is n plus 3t. And now we're going to write that LCD right next to each of the originals. So we're going to write it here, and then we're going to write it right here. Here we go. We'll get, now because there's more than one term, I need parentheses to capture all of it. N plus 3t b equals quantity. N plus 3t, right? I need parentheses to capture the whole thing, dot this fraction. 3w over n plus 3t. Now, I'm trying to solve this for n. N is locked in these parentheses, so why don't we just multiply through by the b? We will get, right, so I'm going to multiply by the b here and the b here, getting nb, not equals, plus 3tb equals, but on the right side, this n plus 3t cancels with that one, and we are left with 3w. Now, we're trying to solve this for n right here. So let's eliminate this term, and then we'll divide by the b. So we are going to subtract, here's our plan, we're going to subtract 3tb from both sides. So if we subtract that from the right side, we'll just be left with nb equals 3w. Now subtract from the right side, 3tb. Now, one more step. Let's divide by the b so we can isolate the n. And just as we did before, there's 2 ways to do this. We could divide the entire side by b. We'll do it both ways. So if I divide the entire side by b, I get this. N equals 3w minus 3tb all over b. And then if we divide each individual term by b, we'll get this. N equals 3w over b minus 3tb over b. And if we do it this way, these b's will cancel. And we are going to get n equals 3w over b minus 3t. So there's a solution for n. Here's a solution for n. They look different, but when you compute, they'll give you the same result. How about this one here? B equals m plus w over 2. Let's solve it for m. So we've got an equation with fractions. We know what to do. We'll get the LCD, right? So the LCD here is just that 2. That's our only denominator. And then we're going to write the LCD alongside each original. I'll write it here, and then I'll write it here. Let's do it. We'll get 2b equals 2 dot, that fraction on the right, m plus w over 2. And now on the right side, those 2's cancel, and we'll get 2b equals m plus w, and we're trying to solve it for m. All I have to do is eliminate the w. It's being added, so why don't we subtract it? So I'll say what we're going to do. We're going to subtract w. We'll get 2b minus w equals m, or if you like, m equals 2b minus w.